So now let's go ahead and try to figure out how we can apply some of the facts that we've learned earlier in this lesson toward solving problems. Number 8 is a problem with a triangle. It says solve for x. We're given that one of its degrees measures 60 and one of its degrees measures 62, and the third is x, which we have to solve for. Now my first question to you would be, before we even get there, is this an equilateral triangle? Okay, now some people might say, well, you know what, it looks like one. Looks pretty similar to the equilateral triangle we saw earlier, right? So some people might be tempted to say yes, but you kind of know from the way I'm talking that the answer is no, right? This isn't an equilateral triangle. It doesn't really matter how it looks, because we're given more information than just how it looks. We're actually given angle measures. That information is more specific than just the general appearance of this triangle. So we have to rely on the more specific information that we're provided with. And we are provided with the fact that, yes, one angle is 60, but a second angle is 62. And you remember that in an equilateral triangle, all the angles are 60 degrees. So that even though this looks like an equilateral triangle, it isn't. Okay, so we've got to figure out, well, what is the measure of x? What is the value of x? What fact do we need to make use of? Well, we're going to make use of the fact that the three angles of a triangle add up. When you add up their measures, it adds up to 180 degrees. So if we take the 60-degree angle plus the 62-degree angle plus angle x, those three are going to have to add up to 180. So let's go ahead and solve for x. Well, this gives us 122 plus x is 180. We could subtract 122 from both sides, giving us x equals 58 degrees. Okay, and that is the answer to number 8. X equals 58 degrees. You can write that over here. 58 degrees. Okay, good. Let's go on to number 9. Solve for x. So here we're given another triangle, and what do we know in terms of numbers in this triangle? We know that the bottom side measures 24 inches in length. Okay, and we're not given the measurements of the other two sides. Now, is this an isosceles triangle? It kind of looks like maybe it is, but we can't assume it. Okay, and it may not be an isosceles triangle. We can't go from appearances. We've got to go from specific information that we're provided with. So what is that specific information? Well, this point on the left here divides the left side into two congruent line segments, which makes this a midpoint. And this right point also divides this other side into two other congruent segments. Notice the two segments from right to left aren't necessarily equal, but the ones on the right, on either side of this point, are equal. So this is also a midpoint. So we've got a line segment that is connecting the midpoints of the two sides of a triangle. Well, what do we call that line segment? It's called a midsegment. Now, what do we know about a midsegment? Well, we know that the midsegment is parallel to the third side and half the measure of the third side. Well, the third side here is a 24 inches side. So that means that x has to be half of 24, or x has to equal to 12. Okay, if that was not really clear to you, and that reasoning didn't make full sense, I want you to go and watch this video again and listen to that line of reasoning, because it's very important that you feel confident with it.